Hello everyone and welcome back to Educator.com. I'm Dan Fullerton, and in this lesson we're going to talk about the Biot Savart Law. So our objectives are going to be to deduce the magnitude and direction of the contribution to the magnetic field made by a short straight segment of a current carrying wire, and derive and apply the expression for the magnitude of the magnetic field on the axis of a circular loop of current. Now, as we get into the Biot Savart Law, please understand that this is probably the most difficult topic in the entire E&M course. So as we go through these derivations, they're probably not going to make sense the first time through, maybe not even the second. These take some work, some hunkering down. They're not easy concepts. So let's start by talking about what the law is. Really, it's a brute force method of finding the magnetic field due to a length of current carrying wire. And to draw this out for you, let's assume that we have a current carrying wire here in black. And what we're going to do is we're going to find the contribution to the magnetic field at some point up here due to just a little bit of the wire down here. And to find the entire magnetic field, we would add up all of these little sections, all of the magnetic field contributions due to all of these little sections of wire dl to get the entire magnetic field. It's not a straightforward process. It's not an easy formula. It's kind of the brute force method. And in our following lesson, we'll talk about a more streamlined method you can use when you have certain symmetries. So let's start off with a quick little diagram. I'm going to say that we have our little bit of current right there. There's current. And we want to know the magnetic field strength, let's say somewhere over here. So that'll be our little bit of magnetic field. I'm going to define then a line from my little bit of current to that magnetic field, and I could call that entire vector r, or I could define the unit vector in that direction r hat. And I think that'll give us the basis for our analysis. If we looked at the whole thing, that would be vector r, just that little bit, the unit vector in that direction, r hat. So you'll see the Biot Savart Law written in several different forms. One form, the differential of the magnetic field, dB, is going to be equal to mu naught I over 4 pi dl crossed with r hat divided by r squared, where we're using the unit vector r. Or, same basic diagram, same basic setup, you may also see it written as mu naught I over 4 pi dl crossed with the r vector, not r hat, divided by r cubed. And those are equivalent because r hat is just the r vector divided by the magnitude of the r vector, which is going to be r vector over r cubed is going to be equivalent to r hat over r squared. So that's the Biot Savart Law. Now, implementing it, using it, takes a little bit of finesse, a little bit of practice. So let's go through some examples where we actually use it.